are live. Oh, excuse me. I can go ahead and say the prayer.
Okay.
That works.
Yeah.
Oh, wait a second.
What's going on?
I'm going to start us off with the prayer.
Okay, cool.
Our dear Heavenly Father, we're grateful for this night that we have been able to come together and work toward completing our pre-calculus work. Father, we ask Thee to have Thy Spirit be with us, that we may be able to be guided and understanding this work that was put before us. We ask Thee to please bless our group, that everyone may be able to be enriched, and that those not in attendance may be able to come to the meeting as well, so that we may learn from one another and do well and succeed in this course. Father, we're grateful for the knowledge and understanding Thou gives us in all our subjects of study. And we say these things in the name of Jesus Christ. Amen.
Amen. All right.
So anyone have any questions from like the review or just anything the last couple weeks they're wondering about?
I mean, what questions do I have? I think I'm good for now.
Yeah, I actually feel better with this test than some of the other ones.
I was actually thinking the same thing.
Yeah,
So-
I like trigonometry a lot better than algebra.
Yeah, I agree. Do any of you know? I know they stress the unit circle and stuff. Do we have to memorize it at all, or are we going to be able to use it? Or
I'm not sure. Have we looked at the test directions or anything yet?
I actually haven't. I should have. I was looking at the review, and it talks about giving values and stuff for different things, but I can't imagine we'd have to memorize it. Like,
Yeah.
I don't know.
It says, so if you go to due date number 2 and then exam preparation, there it says that it just says to know the unit circle, and it's like all caps. It doesn't say memorize, it just says no.
Yeah,
does that mean memorize?
Like going into like if you go further down with the review where it's like the problems to try and stuff to find the values of like sign and stuff, like I mean all that's with the unit circle, so I don't think you're required to memorize every last angle of it. Yeah, I was just wondering because that ain't happening.
Yeah.
Okay, well, we're pretty good for that.
Yeah, I mean, yeah, I looked at the instructions too, so it's like, it says you can't use any outside resources, so no notes or homework either. So I'm guessing we might have to memorize it.
Oh, I see.
And it's actually not that hard to memorize. You just have to like get a few basic things and then you can pretty much calculate the rest of it.
Yeah.
Well, yes, true. It'd just be learning the signs and not getting those flipped up.
Yeah, definitely.
Yeah, I memorized a little formula to calculate off of the other ones.
Cool. Well, since there's only 3 of us right now, if y'all want to go through the extension problems, maybe hit a couple from each section so we have plenty of time for the group quiz.
Mm-hmm. Yeah, we could do that.
Like a million windows open.
Oh, same.
Okay, that's that. Okay. So, solving triangles. I feel really good with the triangles.
I feel like if we feel like super comfortable with something, we should probably skip it for now. Because there are only 3 of us and we don't have a ton of time.
Yeah, I'm fine with number 1 if y'all are on the extension problems.
I went through and I actually did all the problems as like practice. So I'm like pretty good on number 1. I don't know what anybody else thinks.
Yeah, let's go. Let's jump to 2 if y'all are all good with it.
Yeah. And number 2 is pretty straightforward as well.
6 trig functions. Oh yeah. Oh yeah, that actually, the sheet you gave us was really helpful.
Yeah. That's pretty good.
Yeah, but that's just plugging in the values.
Yeah, I just have to find the other side of the triangle and then plugging them all in and whatnot.
Yeah. Sometimes I mess up on simplifying, but that's just me.
My pencil goes. Aha.
Okay. Okay. So if y'all want to move, if y'all are feeling good, if y'all want to move to 3, finding like magnitude and directions and stuff.
Sure. Do we want to like discuss a little bit, just like really, really quick, like what we got, just to make sure we're all on the same page?
Okay, for which one?
Just number 2.
Oh, okay. Go back. Let me pull up.
So what I got, I guess just to start, for the sine of alpha is 3 over the square root of 58.
Mm-hmm. See. But square root of 58 be over. Oh, no, that's cosine. Never mind. See, I make silly errors like that all the time. Because cosine is square root of 58 over 3, right?
Cosecant?
Is that cosecant?
Yeah,
The CSC? Oh, cosecant, sorry.
Yeah, over 3. And then cosine is 7 over 58 over the square root of 58. And then secant is the opposite of that. 58, the square root of 58 over 7.
7. Okay. And then tangent 3 over 7? Or
Yeah.
yes.
And cotangent 7 over 3. Pretty straightforward.
I flipped the first one. I don't know why. I just gotta pay attention.
Okay, number 3.
Yeah, we got the fun stuff. Direction and magnitude.
Oh, here it is. Direction and magnitude of W. So to start, get the magnitude formula, which is just the vector, or the absolute value of the vector is equal to square root of a squared plus b squared. Just plug those in for W. Is square root of 13.
And that's the magnitude, right?
Yeah.
Just to make sure. Okay.
And then you take the sine of theta is equal to b over the magnitude, which is 2 over the square root of 13.
For those, do they want us to simplify it in a decimal or to leave it as a radical? Because I know the homework kind of had us doing a little bit of everything. Sometimes it wanted it simplified, sometimes it wanted it stayed. But I mean, it's not specified here.
Well, so what we're doing here is we're finding.
Oh, wouldn't you plug that into for the angle?
Yeah, you take this fraction and take the inverse function or inverse sine of it, so that you're left with just theta.
Oh.
And then you get that.
33.7 degrees.
I rounded it to 2 places, but it's the same thing, I guess.
I just closed out a window.
And then what you have to do with that is you take the 33.69 or whatever, and you have to subtract it by 180 to get the like the actual angle of it.
Okay.
Does that make sense? Like, it kind of makes sense to me, not 100%, but I think I understand it.
Yeah. I remember the subtracting. Yeah, I just can't totally remember what. Is it one? Hold on. Give me a sec. Is it 180 minus the 33.7, or is it the 33.7 minus 180?
180 minus 33.7.
Okay.
So what it is basically like, this is how I understand it. I'm not 100% sure if that's correct, but it makes sense to me, kind of. So, oh, one sec. Here's the X, here's the Y. And the 0 is over here. All the way over here is 180. And so this is the resultant angle after like doing all of this subtraction. But I think what it wants is it wants that angle. And so to get this angle, you subtract 180 from this, and you have this.
Okay. Okay, so you take the angle the one that you solved for, and then you're seeing what's left, kind of like what's left of it.
Kind of, I think. I'm not like 100. Like I said, I'm not 100% for sure on when to do it, but like this makes sense in this example to me.
Okay.
I think the problem, but I'm not 100% sure. Like,
I won't question the why. I'll just know that it happens.
Okay.
It's already going to be 8. Where did that even go?
Component form of the vector, blah, blah, blah. So that's just using the other equation. You add the two vectors together, and then you times them. Oh, no, that's something different. What? Oh. I'm sorry, I'm looking at the wrong paper. Aha. Y'all know how to do this one, number 4?
What is it? I don't have it pulled up right now.
Finding the component form of the vector given the magnitude is 3.5 and the direction is 205 degrees.
Is that where we kind of work it opposite, where we find the inverse of the degree?
I
feel like I did a dozen of these in the homework, and now that I actually have to use my brain,
yeah, same. That's kind of how I was like. But for this one, it gives these two equations. A equals r cosine theta, B equals r sine theta. And you essentially just plug those in, and that gives you A and B of the vector.
Oh, you just solve for them.
Yeah, because the vector in this component form is A and B. So you literally just solve for A and B, and you plug these in, so you get 3.5 cosine of that degree, and then 3.5 sine of that same degree, and that's what you get.
Oh, okay. And you just solve for the numbers now. Oh, that makes sense.
Yeah.
I know there were problems on that in the homework. Like,
yeah.
I feel like I just go through them sometimes, and all the stuff just jumbles together.
Mm-hmm.
Okay. I don't want to rush us through anything, but I've only got like another half hour on here because my husband's group meets at 8:30. So okay. I've got to get off regardless at 8:30 so he can get on. But
okay, let's start on the quiz then.
Yeah, let's go ahead and do that. Sorry guys, I know we started later today and
no problem.
Be so done with these meetings next semester. You guys are great, but it's hectic.
I am too.
Okay. Anyone want to submit this week or?
I can try if you guys want.
Okay.
Sure. Okay.
So the first one's one of those trapezoid things, I think.
You want to swim from one side of a river to another side. Assume your speed is 3 miles per hour in the west direction with negligible water velocity. When you reach a certain point, you will encounter water flow with a velocity of 6.2 miles per hour in the north direction. What is your resultant speed and direction? It may help to draw a picture. Yeah, I think what you said about the shape or whatever is correct.
So 3 miles an hour in the west direction.
So
West for me.
West in the west direction. So and then
so is the speed counting as the distance?
I think essentially that's what we're doing.
That doesn't make any sense, but
What is your resultant speed? So does this
resultant speed, okay.
does this make any sense at all? I'm not even sure if I'm doing that right, but it's like 3 miles per hour that way and then goes north 6.2 miles per hour.
North direction.
And then is what we're doing, are we just solving for that?
For
Water flow velocity, hold on. 6.2 in the north.
What's your result?
Yeah, because like if you're going west and then north, yeah, so then that would just be is that the overall direction? So I guess it's kind of like the vectors. I mean, we're putting them together, right?
Yeah. I think so. And then it also wants the direction, so we're going to need this angle.
And we just say your speed is 0 because you stopped swimming. Waterfall.
So, yeah.
Does it matter at all that your speed is one thing, but then the water flow speed is another?
It doesn't give us that, so I don't think we have to worry about it.
Okay. Well, because first it tells you that you're swimming 3 miles an hour with no water speed. And then at the certain point, whenever you switch, it says you encounter a water flow with a velocity of 6.2 miles an hour. So is your speed still 3 miles an hour and the water flow changing?
Well, it's so you're swimming this way and you have a water pressure coming straight down on you. That's what it's saying. So it's asking how that's going to affect your speed and the direction at which you're going. So it's going to force you down south and probably slow you down as well.
Oh, I see what you're saying. Yeah.
So I guess kind of like that.
3 miles an hour, the water.
You're swimming, and then the water is pushing down this way at 6 point whatever miles per hour. And that's going to push you downward.
So how do we calculate that, though?
Right? Yeah, I'm like, what? we did nothing like this. Yeah, I'm thinking it's like the combination vector maybe, but I'm just not understanding what values are like. We don't have angles, we have speeds. Like how does speed, we don't even have distance to figure out how far they went or the time it took them to get 3 miles, you know?
Yeah. We're giving very little information.
Okay. Draw a new picture.
When you reach a certain point, you will encounter water flow with a velocity. Oh. So you're
so you're still swimming west, but the water flow is now going in the north direction. Is that?
Oops.
Yeah, so I mean it pretty much is the picture that you drew. I'm just trying to figure out how we figure out the resultant speed and direction.
I have no idea.
So is the water coming from the north down to south, or is it coming from the south up north?
It just says in the north direction. So I'm thinking it's going north. So it's going from the south to the north.
Okay.
Okay.
I drew that wrong. Oh well.
So then do we find the magnitude of those vectors and combine it? But then how do we even... I just feel like speed is not even helpful here. Like, were you swimming an hour? So you got 3 miles. Were you swimming half an hour? So it's only 1.5 miles. I feel like we're missing something here.
Want to swim from one side of a river to the other side.
Let me check out the textbook. Because it says we can use our textbook. So let's see if it has any similar problems to toss ideas on.
Like, doesn't, I don't know. When you reach a certain point, you will encounter water flow with a velocity of, or here, there's, but here. I feel like this level of math is far above what they taught us.
Exactly, you're right. Like we're studying pre-cal and we're being tested over calculus.
Or like calculus 2 or something.
Oh gosh.
What is your resultant speed and direction? Hint, draw a picture. Well, that's not really doing anything.
We each have like 3 different pictures, so.
Hint, take a higher math class.
Right?
Yeah.
Wait a minute. Okay, well, there's a problem in the book, but there's a lot of in chapter 7, there's a lot of river flowy questions.
Really?
Yeah, but they all have more information, I think. They're like, a river is 2,000 feet wide and flowing at 6 miles per hour from north to south. The woman in the canoe starts on the eastern shore and heads west at her normal paddling speed of 2 miles an hour. In what direction will she actually be traveling? So I guess that's kind of similar. It's the water flowing and her speed. But see, I feel like in this example, they're giving the speed, they're giving measure it clockwise from north, they're giving the width of the river.
Yeah, we literally just have the speed you're going and the speed of the water.
Directions.
Yeah, and direction. That's true.
Yeah, in fact, there's problems that on page 521, it talks about the same thing. Like a woman's paddling, but the river's flowing. So how long is it going to take her to get across the river? But
I don't feel like we studied this. Like, I don't feel like there was any problems in the homework or in any of the assigned things that we did.
Is it like that tree stump one we did Tuesday or yesterday? But we were given angles with that one.
Yeah. I mean, you have a 90-degree angle.
All right, we're a third there. Well, maybe we'll move on to number 2 and come back to number 1.
Good choice.
Because I don't even know. Let's do that.
We have, okay, wait. We have, yeah, never mind. I don't think that'll work.
You got an idea, I'm all ears.
I was just going to say, we have the 90-degree angle, and we essentially have 2 of the sides. If it were making a triangle, we could figure something out, but I don't think that's what it's asking.
I mean, worst case scenario, that's probably the best idea we got.
I don't know.
Yeah, I just feel like, I mean, speed is distance and time. Like, we have no value of time here. Like, I don't know. It's like when you reach a certain point. What point?
Yeah.
So, yeah, my best guess is to treat it like a triangle and work that magic or something with law of cosines. I'm going to scan the book again if it shows. Oh, wait a minute.
Equation.
Doesn't help. Okay, hold on. Okay, I might have found an example problem. No, not that one. No, I don't. Direction of the plane. Portion of distracted out of the airspeed. Okay, if I don't know if any of y'all have the book open, but on page 517, it's talking about a plane flying and the wind direction and speed. And I think that might be the same thing with the river, because I found the river question and went to the section it was referring, and this is what it gave me. So I know it's talking about a plane and wind direction, but I think that's kind of the same as person swimming and water flow speed, maybe.
Yeah.
Yeah, I think so.
So let me and they drew like a picture, then they flipped the picture. Oh my gosh, like what is this? This isn't even.
Where is that? Okay, the heading of an executive Learjet has a bearing of 320 degrees. The wind is 70 miles per hour with a bearing of 190 degrees. Given that the airspeed of this plane is 400 of the airplane.
Yeah, see, right before that example 9, like the paragraph right above it describes the drift angle and all this other stuff, but I feel like we weren't given enough information to solve the entire problem.
Between that and that.
It says if an airplane heads directly against the wind or with the wind speed is subtracted from or added to the plane. So if you're swimming at If you're swimming at 3 miles an hour to the west, and then you encounter something with 6.2 miles an hour in the north, well, I guess that's not really against or with. Would you gain I don't know.
Let me see. Drift angle. Wind's course and ground speed. Wind direction speed. Plane's heading and airspeed. Color bearing electricity.
I don't know if this will help, but this is kind of like what I was thinking. I don't know if that would like do anything.
Going west. It's going north.
Then this would be the direction of the swimmer after the north velocity hits them. Maybe. I got no clue.
That makes most sense.
See where you're going with that. Gosh, like, I don't even know.
It doesn't give us like specific angles though that we can work
Yeah.
on.
I mean, the only thing we have is that it's north and west, so that would give us that 90 degrees.
Yeah.
But I mean, I just don't understand that it only tells us speeds. It doesn't give us actual distance, because if they were going 3 miles an hour, what if they were swimming for 2 hours? That'd be 6 miles, you know? I feel like it's not giving us an information to accurately calculate any part of it.
It just,
Yeah.
so what it wants is just the speed. It just wants the speed and the direction.
So northwest is the direction.
Oh yeah, true. Hey, we got half points, right? Speed would be,
And by direction, I think it wants like a specific angle.
Oh, probably.
If it were northwest, then it would be
like,
approximately 135 degrees.
Give or take, yeah, I guess.
well, because if you're going 3 miles an hour and the water's going almost a little more than twice as fast, would that put you at a little more, instead of being like exactly a 45, would it make it a little?
You're right.
Hold on. Where'd my calculator go?
So, could you basically use like the log, like the signs and stuff? So you can use this distance and that distance kind of to find the length of this, or the measure of these two angles, and then apply them over to this triangle. And then that'll help you find.
Yeah, we'd have to find the other side first, the side opposite the 90-degree angle, and then we could use that as a ratio to find the other two. I think. Yeah. Or no, we could just use right triangle trigonometry.
A squared plus b squared.
Yeah.
Oh, and that would just give us the like.
Oh, I don't know where my calculator went.
Here, give me a second, guys.
Oh wait, never mind. It's sitting right in front of me. So like roughly 6.9-ish, 6.89 would be the length of that side.
And then we could use 6.89, you said?
Yeah, round enough.
So then what? That doesn't make sense. Oh. My calculator was in radians mode.
Oh, nice.
Half degrees. There we go. So then the angles for the other, or the measurements of the other two angles would be 64.18 and 25.82.
$25.882 is on the 3 side, right? Opposing 6.2.
Just 82, yeah. So this one would be 64.18.
Yeah.
And this one would be 25.82.
Okay.
Then
So you could just use that degree to find the direction. Then would it be 25.82 degrees northwest? Or would it come down from the 64 degrees northwest?
I think it would be the 64.
Okay. And then the speed would just be the 6.89.
I think so.
Maybe up here. Sorry, guys.
Okay, so we think we got that first one done, right?
I would get sure.
More.
I don't know what else there is to do. I mean, that's the only thing I can think of. So, yeah.
Solve it like the trapezoid.
Yeah. So we just found the length of the hypotenuse and then used the other laws to get the angles.
Okay.
I mean, kudos to you guys, because I honestly think maybe an angle or something should have been provided, but I mean, that's all you can really do is just try to solve them and go from there.
Yeah.
And then for those next two problems, I know part of that first or that second one. I'm not entirely sure if it needs to be done further. But this is what I have so far.
Okay. And that's number 3. Yeah.
Is it?
Yeah.
Oh, okay then.
Did you already do 2?
Polar equation.
2 is right here then.
R equals sum cosine. Oh, here. I can double check 3.
Yeah, that'd be good. I wasn't sure if it was wanting us to solve for X or Y. I think it's X though.
Oh, you're right. Polar equation.
Now down there on that bottom, that's a 3y/7.
Yeah.
It's just really light.
Yeah, sorry.
All good. Okay.
Okay.
X equals R theta plus R sine theta.
Number 4.
And then it says polar equation.
Hey, what happened? Sorry, today is a crazy day. I swear. Okay.
We have
3
theta. 1, 2, 3, 4.
Okay.
We have
So that's at a 235-degree angle, right? 4π/3.
it's 240.
140.
4π/3. Yeah, that's 240.
Yeah, it's 240.
Oh, yep, almost there.
So then it would be 1, 2, 3, 4. So it'd be right here. But then it wants polar coordinates that are located in the same place. Okay, so then we just have
9.
this is 30, this is 30, this is 60. So we have -460.
On number 3, would we be solving? Did we agree we're solving for X or Y?
That's what I wasn't for sure about. So I just solved for X.
Would that just be 3 tan theta over Y?
what did I get? Oh.
I don't know if maybe I'm looking at it too simplistically, but just squaring both sides would give you x and y equals 3 tangent. And then I don't know if you would just divide and solve for x and then I don't know. I don't know if it's that simple. Probably not. I'm probably underthinking something. But oh no, because then you would still have no, never mind. Yeah, that would.
So here are the answers to 4. Right down here we have it's kind of like all over the place. Here's the question. It's in degree form, it's 4 and then 240 degrees.
Yeah.
And then here we have -4 and 60, and then 4 and then -120.
Okay. Yeah, cool.
But then what were you saying, Ariel, about 3?
Here. Would it like I said, I don't know if I'm just oversimplifying this. If you just squared both sides, and then so that took away the square from the x and the y, and then it gave you the square root of 9 y over x squared, could you just take the square root of separately since they're being multiplied and have that be 3 and y over x, which y over x would be tangent. So then you would have x plus y equals 3 tangent theta. And then
why would you square?
Or sorry, square root them.
Oh, square root them. Okay.
Sorry.
Oh no, fine. Square root.
Wait, so what were you saying might be the answer then?
If we were solving for x, I thought it might be x equals 3 tangent theta over y.
I think for this one, we're solving for r.
Oh.
I'm pretty sure.
Okay.
I mean, so
oh, sorry.
Another. Oh no, you're fine. So this is the equation that I had, but then can you square root that so that it's r equals plus or minus the square root of 3 tangent theta? Or can you not do that?
I mean, since 9's being multiplied by tangent, I'm pretty sure you can square root them. But
Okay.
would it be well, I guess it could. Yeah, it could be a plus or minus.
Yeah.
310. Because I'm pretty sure mathematically those would come out to be the same thing, but I don't know if playing it safe would be. Well, no. Well, you'd have to square root it because you'd have to get r isolated, right?
I'm pretty sure. Yeah.
And I feel like since they gave you the 9, that's kind of a push toward it comes out to a good square root, not a radical or something weird. So I don't see the issue with plus or minusing that one.
I'm going to take that as a yes. We should do that.
Yeah, sounds good.
That, and I'm just done with math today.
Sorry for jumping everywhere.
No, you're fine. Oh, okay. Guess that's it. Does anybody have any other questions?
Not tonight, no.
Right, yeah.
Well,
Done with for tonight.
yeah. Even if I did, I wouldn't ask them because I'm just done. I'm just kidding.
Yeah. There you go.
Well,
Okay.
sounds good.
Sounds like a plan.
Good luck to you guys on the test.
Yeah, thanks, guys.